So RC phase shift oscillator. So it is a fixed low frequency oscillator. It consists of amplifier circuit and RC shift feedback network. A feedback network consists of three RC section in cascade connection, each producing 60-degree phase shift. So this is the feedback network structure. So RC in a three section. So each section produce 60-degree phase shift, and totally we get a 180-degree phase shift. So this is a input signal. So VI 0, so which gives the positive signal, and this is the output V0, so it will get a 180-degree phase shift. Resistor and capacitors are arranged in a ladder fashion. It is also called as ladder network. So all resistors and capacitor values are same for a partition frequency. So it must be all resistor and capacitors are in a same value. And then connection. So here we have a R1, RC, R2, and then RECE. So this R1, R2, RE for the biasing purpose, and here we have a feedback network structure. So it have a two stages. So first one is the amplifier stage, and second one is the feedback stage. So this is the feedback network. So part of the output is given as again a input, so it will produce the 360-degree phase shift, and this is the equivalent circuit of our RC phase shift oscillator. So HIE, here IB current, and this is C and E emitter and capacitor. So HFE, IB, RC, C, R1, C, and R2, R3. So these are the equivalent circuit. So for the simplification purpose, we can further simplify this equivalent circuit as this one. So we want to calculate the loop current I1, I2, and I3. So to calculate loop current, apply KVL to the loop 1. So then we can get the equation minus HFE IB RC minus I1 RC minus I1 divided by j omega C minus I1 minus I2 into R, which is equal to 0. So from this we can calculate HFE IB RC I1 RC plus I1 j omega C plus I1R minus I2R, which is equal to 0. So segregate the I1, I2, and then IB. So for this we can segregate I1 into R plus RC plus 1 divided by j omega C minus I2R plus HFE IB RC. Here the IB current, which is equal to I3 because of feedback current. So and then apply loop 2. So KVL to the loop 2. I2 divided by j omega C plus R into I2 minus I3 plus R into I2 minus I1, which is equal to 0. I2 j omega C plus R I2 minus I3 plus R I2 minus R I1. So we multiply this R into inside, and here this R into inside. So and then we can get the second equation as minus I1R plus I2 into 2R plus 1 divided by j omega C minus I3 is equal to 0. So this is the equation 2. So apply KVL to the loop 3. For this we can get I3 divided by j omega C plus I3 into R plus R into I3 minus I2. From this we can calculate minus I2R plus I3 into 2r plus 1 divided by j omega c, which is equal to 0. So this is the equation 3. Then we can calculate as a matrix form. So each loop has a matrix form. So we can calculate first row. So r plus rc plus j omega c into 2r plus 1 divided by j omega c into 2r plus 1 divided by j omega c minus r square minus of r into r into 2r plus 1 divided by j omega c minus 0 plus hfe rc into minus r square minus 0. So from this we can calculate r plus rc into 3r square minus 1 divided by omega square c square plus r into rc into 4r divided by j omega c minus 1 divided by j omega c into 3r square minus 1 divided by omega square c square plus 4r j square omega square c square minus 2r cube minus r square j omega c plus hfe rc r square, which is equal to 0. So from this above equation we can segregate real term and imaginary term, which is equal to 0. So at resonant condition XL is equal to XC, then there is no imaginary part term, that is we can equate that imaginary part term which is equal to 0. That imaginary part term is minus r plus rc into 4r divided by r 4r divided by omega c minus 1 divided by omega c into 3r square minus 1 divided by omega square c square plus r square divided by omega c, which is equal to 0. So again we can multiply this term in inside minus 4r square omega c minus 4r rc divided by omega c minus 3r square divided by omega c plus 1 divided by omega cube c cube plus r square divided by omega c, which is equal to 0. So from this equation we can commonly outside 1 divided by omega c. So after this we can simplify 1 divided by omega c into minus 6r square. So 4r square and then minus 3r square, 7r square plus r square, here 6r square minus 4r rc plus 1 divided by omega square c square, which is equal to 0. So and then from this we can calculate 1 divided by, so this 1 divided by omega c goes outside means which is equal to 0. From this equation we can get 1 divided by omega square c square, which is equal to 6r square plus 4r rc. So we want to calculate the omega value. For this 1 divided by c square into 6r square plus 4r into rc. Here rc is k into r. Substitute that k into r for rc and then we can get 1 divided by c square into 6r square plus 4r square k. So we want to know calculate the frequency, that is resonant frequency. For this, so we can substitute omega is equal to 2 pi f. From this we can calculate f is equal to 1 divided by rc into square root of 6 plus 4k. So f is equal to 2 pi rc into 6 plus 4k. Next, condition for oscillation. So real part which is equal to 0. So r plus rc into 3r square minus 1 divided by omega square c square minus 4r divided by omega square c square minus 2r cube plus hfe rc r square, which is equal to 0. So from this we can calculate. So we multiply this term in inside. 3r cube minus r omega square c square plus 3rc r square minus rc divided by omega square c square minus 2r cube plus hfe rc r square 4r divided by omega square c square, which is equal to 0. From this above equation we can calculate r cube minus 5r divided by omega square c square plus 3r square rc minus rc divided by omega square c square plus hfe rc r square, which is equal to 0. Substitute omega square, which is equal to 1 divided by c square, 6r square or 4r rc in above equation. We can get this equation. So from this we can calculate hfe, which is equal to 29 divided by k plus 23 plus 4k. So this is very important. So hfe is otherwise known as gain, otherwise we can represent this term as a. So this is the condition for oscillation. Thank you.